So, hello everyone. I'm very happy to see you here. Welcome to this talk. And as said, we are going to talk about building a universal policy engine for Kubernetes. Building a universal policy engine, that sounds big, no? And a bit, it's a big word. I really mean it. It's not a joke. And it's maybe a bit bossy, but let's see how we can do it. So it's a bold statement. For that, let's set the stage a bit quickly about the whole thing, and then we get into specifics. So we can see here a slide. This comes from the CNCF annual survey of 2022, the cloud native biggest challenges. And it's basically the lack of training, so knowledge, and security. That's the two big things that we are missing. The lack of training means just being here with the conference, absorbing knowledge and so on. And security means having a tool to take care of all that security that is needed for your container. And also observability tools are up, on the rise and have a biggest growth and so on. Organizations favor GitOps and so on. So it's what is expected. Another key finding from the CNCF annual survey is this one. It says here in this extract, containers and WebAssembly enable loosely coupled systems that are resilient, manageable, and observable. Yada, 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 the usual. We know about containers, but WebAssembly, what's that? Can you raise hands, after lunch and show who has heard about WebAssembly before? Does anybody have? Yeah, I see some people. And who of those have actually used WebAssembly and deal with it or deployed? I see less hands. Well, in this survey, it says that 37% of people have had some experience deploying apps with WebAssembly. Also, one thing that we need to have in mind is the languages, the language landscape. Here is another slide. This comes from the Stack Overflow developer survey. And you can see a lot of languages, only some of them, not all of them, because there's a lot. And it says there on the top left, loved versus dreaded. So, yeah, what we get from this, writing code is opinionated, of course. There's a lot of choice. We can use a programming language. We can use a domain-specific language. Certain languages are better suited for some things than others. Languages are tools. And then we are human. No? We are beautiful and also all those things. And we are also subjective. So we have preferences. OK, back to the topic, policy platform. What is a policy platform? It runs policies. What's a policy? It's very simple. You have information coming in. Let's say JSON, then you make some evaluation on that JSON, deciding if this is OK or not, and then some information going out. I accept this, I don't like this. Quite simple. A policy platform defines those policies. You have a list of policies, you deploy them, and so on. And a policy platform also enforces those policies. You have a system, in this case a Kubernetes cluster, and with those policies you make it sure that it's secure. So you enforce it. And also, the policy platform provides insights of all of that. What amount of policies are running, how maybe you want to write policies about policies, and so on, and provide your users with some information there. OK, talking about policy. It seems obvious that nowadays we want to do everything as code. So we have policy as code. We want policy as code because we don't want to go through the UI, clicking things and so on. We want to actually shift left. We want to have things earlier in the process. For example, we want to improve our security posture. That means shifting left, having the code of the policy earlier in the process so we can infer things from it and gain knowledge and so on. Also, we want to enforce some compliance rules. We have the policies. We have it as code, so we can do policies about the policies again. And the key traits of code, policy as code is as usual, reproducible, scalable, auditable, testable, the usual as code, So then, OK, we have talked about the policy engine and so on, but we still need to cater to all those people. We are building a universal policy platform. So we have different personas. All of us go through different personas, taking hats in and out. For example, one of the personas is the policy consumer. It's the one that just takes the policy, runs the policy, and takes care of setting the settings of the policy correctly. For example, here we have Christian. Christian, who was a father recently, doesn't have much time for things, and wants policies that are easily configured, tested, and iterated on. He doesn't care about anything else. That's the policy consumer in this case. But maybe we have a policy developer, somebody that really doesn't run the policies, but just develops the policies. And here we have Diane. Diane is our policy developer. Diane has an amazing idea for a policy. It's so amazing that it could be a startup on itself. So maybe it's a policy that checks for all the resources in the cluster, and when it's at night and so on, just powers things on to just don't waste any energy and so on. There's some startups already doing that. It could be a policy. And Diane wants to use specific libraries that are super powerful of her specific language. We also have a persona of the policy distributor. That's the one that doesn't write the policy, doesn't use the policy, just moves them around. No? And here we have Simon. Simon doesn't want to learn anything about the policy engine. And actually, he's a bit snack about it. You can see him, And Simon, what wants is industry standard artifacts. Those policies need to be industry standard. Simon wants an easy way to have software bill of materials, signatures for those policies. Do you know this salsa, slsa.dev, and so on, these kind of things. We have a different persona also, which is the engine operator. That's basically the Kubernetes administrator, in this case, that deploys this policy engine and so on. And here we have John. John is actually happy with his life because his engine of choice actually works quite well. And John wants an easy deployment of that engine for policies, and easy maintenance, having CI/CD for that engine and the policies, and so on. Last but not least, we have the engine developer, an integrator. In this case, is Irma. You can see her there by the back. And Irma is the one that is actually developing this policy engine. And Irma wants a modular policy engine. She doesn't want a policy engine that is just the end goal. She doesn't want a policy engine that you just deploy, slap a UI on top, and that's it. No, she wants to become infrastructure for something bigger. She wants enough users that the policy engine is just a given, and you build bigger and better things on top. And yeah, we have way more different personas, but yeah, they don't fit on this slide. I think it's enough. Okay, specifics now. We talked about WebAssembly. What happens if we use policies written in WebAssembly? Well, WebAssembly is a binary instruction format. So it's kind of like a common target architecture for languages. So you compile the same way that you compile Go for Linux. In ARM, you can compile Go to WebAssembly or Rust and so on. That means that for us, the policies are super small. It's just JSON in, JSON out. Everybody more or less knows how to just parse a JSON, take a decision, and put the things out. So the policies are 0.5 megabyte, 2 megabytes big. As we have said, we can compile WASM, WebAssembly, to WebAssembly from very different languages that have that support as a common target architecture. And WebAssembly is secure because it has it's a sandbox, it has memory safety, control flow integrity, protected call stacks. It's actually quite secure, and it's portable. You have your little WebAssembly binary, and you can just ship it around because you just compile it once and run it everywhere. Think about the personas that we were talking before. If we use whatever language, then maybe we make the policy developer happy. They can just write the language, the policy, however they see fit. That means that they use actually Git, and they use the libraries of the language. If you are used to Go, you use the libraries of Go that you're used to. You use all your tooling, Go, Go Deb, all the lintings, all the things that you already know. The same for other languages. And WebAssembly modules, WebAssembly binaries, have first-class support in OCI registries. The same way that you push and pull a container image to your registry, or push and pull a Helm chart to your registry, you can do the same with WebAssembly binaries. It's just there. Even Docker registries have support for that, and so on. That means that you have an easy supply chain security, because if you know how to deal with containers, you already know how to deal with this kind of policies. And the policies can be executed outside of the Kubernetes cluster. You don't need the full Kubernetes cluster in CI/CD or whatever. You just take the binary of the WebAssembly policy and run it outside with a little CLI that runs the same code path as inside. Means shorter the developer loop, easy CI/CD, and so on. You can see where this is going. And where this is going is Kubewarden. Kubewarden is another policy engine. Maybe you know of OPA, Gatekeeper, Kyverno, and so on. We are not the first ones arriving to this landscape, but we are here. I'm the maintainer of Kubewarden. Kubewarden is a CNCF sandbox project. As usual, that means that it's open source, vendor neutral, and all those things. It's production ready. We are already in 1.6.0. That means that we are following Semver, and yeah, we have several features and more to come. And we use policy as code with WebAssembly modules. That informs an architecture in Kubewarden that is modular. We have the OCI registry on one side, the policy server that gets the policies and runs them and executes them. Then we have a Kubernetes controller that just schedules the policy servers and the policies inside of the policy server. We have also KWCTL, which is a binary CLI that you can use outside of the cluster, and more other modules. OK, you now know a bit of it. How do you write those policies? There's 4 ways. The first one, using a domain-specific language. So maybe you already, guys and folks, know about Rigo. Who here has used Rigo in the past or in the present? I see some hands already. I'm not going to ask if you like it or not. You can just ask yourself that question. It's a nice domain-specific language. Of course, it's a domain-specific language. There's going to be a limit on things that you can do with it. You can use whatever language, SDK, because, again, WebAssembly compiles languages compiled to WebAssembly. We provide some SDKs, and we are using that with WAPC. I will talk about that. Or you can use YAML. You don't want to write any code, and you just want to specify some settings in YAML, and you're done with the policy. There's a 4th option, new in Kubewarden from 1.7.0, about to be released this week. And that's using WebAssembly with WASI. Ooh. What's that? Here's where it gets spicy for later. So I have a little surprise for all of you, and I hope that we can enjoy it. So let's go through this kind of writing policies. Writing policies in Rigo. Again, you have one language, which is the Rigo domain-specific language. We have talked about OPA and Gatekeeper. Those are both policy engines, and that means that we have 2 frameworks. We have the OPA framework with its built-in functions that you target and you call in your Rigo code, and you have the built-ins of Gatekeeper. For Kubewarden, we compile Rigo to WebAssembly. We compile specifying which framework are you using, and then you get your WebAssembly binary, shipped as a Kubewarden policy, and that's it. Pretty simple. This means that the policy logic is included in that Rigo DSL. So the policy logic is included when you compile that, and then you ship it, and that's it. The second option, if you remember, of 4th, was using YAML. Writing YAML means that the policy logic is already implemented inside of the policy, and you just configure the policy with the YAML. So you take a policy that already exists from, for example, artifacthub.io or from your company and so on, and you pass some settings in the spec.settings of that policy when you do instantiate the policy CRD, and you have just configured your policy with YAML. No need to write any code. But what about if you don't file any policy that you need? OK, 3rd case, writing your policy on your own using a language SDK. You make your own. Currently, we have support for SDKs on Go, Rust, C#, Swift, and TypeScript. We can always add more because more and more languages support WASM as a target architecture, and they keep growing. So that's good news for us. How does it work? You have a guest of the SDK and a host of Kubewarden. The guest provides some functions, and the host of Kubewarden provides some other functions. And all of this works with WebAssembly procedure calls. That means that both programs basically call functions of the other program, just procedure calls, as it is. This means that it's bidirectional, and it's performant. It's quite fast because everything is on memory. You just call functions, and that's it. Also, talking about bidirectional and so on, the Kubewarden host has functions because we allow for mutating policies, context-aware policies that just query about the state of the cluster and so on, the usual from a policy engine, the usual features from a policy engine. If you want to create your SDK for a new language, that's just as simple as writing a little small WAPC guest SDK for that. We can help you as a Kubernetes team. We are happy also writing new SDKs. And with that, you have already the whole picture for that. The fourth way, if you remember, was using WASI. This is coming from Kubernetes 1.7.0, which is about to be released. And what's WASI? Well, remember WAPC procedure calls. WASI is a system interface. You get WebAssembly, and you interact between WebAssembly code with system primitives. That means SD-out, SD-in, SDR, envars, the usual thing, Unix-like, no? I mean, the usual. That means that you can take something that is a bit more low level. You take a step back, in a sense, and run something that accepts from SD-in and outputs to SD-out. That's all you need, no? And that provides a nice platform for bleeding edge things with WASM. Bleeding edge languages, things that are just not yet well supported with WebAssembly. Of course, it's better to use WAPC because it's faster and more, it's faster. Okay, SD-in and SD-out. What does that mean? Maybe we can recompile a project into WASI, WebAssembly with WASI. Recompile a project. That sounds big. Okay. How about we recompile the whole Kyverno into WebAssembly with WASI? If you remember, there's OPA Gatekeeper, and then there's another policy engine besides Kubernetes that is Kyverno. Yeah, let's try that thing. The Kubernetes ecosystem doesn't really care about how a policy was written because it's just modular, so whatever you put that respects the API is going to run the same. So what's Kyverno? For those that already know, then you know, but for others, Kyverno labels themselves as a no-code policy engine. That means that they don't use any code, and you just use YAML. Actually, if you look into it, you realize that they use YAML, but they have their own variables system, in a sense, and they have their own templating in that YAML. So yeah, it's kind of like DSL of sorts. It's not only YAML. You put your YAML from Kyverno in your CRD, and that's it. Kyverno is written in Go. So far, so good. How about we use Kyverno function libraries, and we just call that from inside the Kubernetes policy? Not yet. That's WAPC. But what we can actually do is compile the whole Kyverno into a Kubernetes policy and run it with SD-in and SD-out. And that's now possible thanks to the Go compiler, the official Go compiler from 1.21, from this 3 weeks ago, which allows for WASI support. This work was done by a colleague, Flavio Castelli. He's awesome. And this policy is already available. It's publicly available. If you are curious about it, you can have a look on GitHub, Kyverno DSL policy. So what are the challenges of doing this? It's a bit big, no? So let's see. The Kyverno code base is actually huge. It's big. Kyverno, if you look at its architecture, you have a Kubernetes controller written in Go. And inside of that Kubernetes controller, you have some logic for your policies there also. So you have all those things, no? It has a long list of dependencies. This is not because of Kyverno itself. Of course, if you use a function from OpenTelemetry and only a function, you're pulling the whole OpenTelemetry, and that brings the dependencies of OpenTelemetry, which is quite big, and so on. But this is also Go, in a sense. It's how the ecosystem is built, and once the ecosystem matures, no, there will be less dependencies. But there's a long list of dependencies. You need to compile all of those into WebAssembly, which is somehow a new architecture. So you really need to check for those dependencies and maybe upstream some changes. And that's what we did. Flavio upstreamed some support for WebAssembly on some of those libraries of Kyverno. And also, Kyverno, it's quite big. We, as Kubewarden, we already have our Kubernetes controller. We don't need a second Kubernetes controller. We can drop that. The same for other things here and there. That means that we fork and trim Kyverno and drop a lot of things. Of course, this cannot be easily upstreamed because it's just dropping things. What could be upstream is doing a whole refactor of Kyverno to separate specific libraries that run their policy logic and so on. But that's a task that is not simple, but it can be done. And as a challenge, we need Go 121, which adds WASI support, which is enough for us to build Kyverno. You run Kyverno, the policy, and you do a Go init. You do the whole thing. You have the initialization of the whole Kyverno, which is with its own initialization of things that we don't care about so far. You also have the Go init part, which is, you have the garbage collector of Go starting and taking, initializing and so on. And all of this is going to happen every time that you run the policy, that you query, eval the policy. You cannot have Kyverno running and then just trigger one evaluation. No, you are calling the CLI tool, so to speak, at once. This can be changed in the future, but this adds a big overload. So what are the limitations then? The limitations is the policy, the resultant compile policy, is huge also. It's 90 megabytes instead of 400 kilobytes or 2 megabytes that it should be. The first startup is low, if you remember. The Go init garbage collecting, the init from all the Kyverno things. That means that WebAssembly just-in-time compiler for the bytecode needs to run, and it's running every time. And also the execution is slower. Normal policies for Kubewarden run in microseconds, 1 microsecond, 10 microseconds, because it's just calling a function and dealing with JSON. But this means starting the whole thing in Go, so it's going to take a bit more time. For us, it's no problem. Kubewarden can still run with policies that take milliseconds. And the API server of Kubernetes and the webhooks for admission and mutation and so on can still work. There's no problem, but it's there. For the first startup, we can actually cache that just-in-time compiler optimization instead of the WebAssembly binary that we obtained from the beginning. And also the maturity. We have just done this proof of concept. It's actually experimental, and that means that we have, for now, not decided implementing support for Kyverno variables, for mutating policies. We have Kubewarden mutating policies, for context-aware policies, or generating policies of Kyverno so far. If there's interest from the community in using this kind of policy, we can always work on it. Or maybe there's going to be more PRs from the community bringing these features. OK. What about the future of that Kyverno DSL policy? Well, the first thing is waiting for the official Go compiler to provide an export of all the symbols, of all the functions, and so on. And then we can use WAPC. That's coming. We just need to wait a bit more, and it's coming. OK. I think that this is quite cool. Suddenly, we wanted to do a universal policy engine. So we are trying to separate the needs of those personas. And now we are providing several different ways of writing those policies. So then there's several different ways of consuming those policies, each for every persona. In the case of the DSL policy, we can also do the caching and so on and provide docs on how to run it. But yeah, that's it. So as a recap, building a universal policy platform. First, cater to personas. See what everybody needs and try to build a community that helps with all those needs. That's the first thing that you need to ask yourself. You don't want to be a local maximum in this case. And then we have decided to go with policies as WebAssembly, which, as a consumer, you don't need to care. You just consume the policies normally from your pull from the registry, and that's it. And as a producer of policies, you can write them on a DSL, such as Rico, use YAML with an already written policy that includes the Kyverno DSL policy, or you can use a language with an SDK. In this case, for Go, Rust, C#, Swift, TypeScript, and so on. And as we have said, this informs a reusable and maintainable architecture. You have the OCI registry on one side, the policy server that evaluates the policies, the controller that schedules the policy server and the policies, KWCTL, which is a CLI for running the policies outside on the CI/CD and so on, which, hey, Sounds good. I hope that at least I have made you think a bit on how to build a universal policy platform. And then the question is, what's next? What's next? Looks okay, but maybe I'm missing features. What's next? We have the audit scanner module coming. That's another binary that you run in a container and the rest of the stack knows about. The audit scanner is a feature that catches up also with other policy engines. And it allows you to have like a cron job of what's happening in the cluster. Not only you check things coming to the cluster, an operation for a creation of a pod or an update of an ingress or whatever, but you just evaluate what's already happening on the cluster. Maybe because you deployed everything on the cluster and then you deployed Kubewarden and you deployed it on monitor mode just for informing you, but not blocking everything. And as other policy engines, it reports back using the policy reports CRDs. The policy reports CRDs is a CRD that comes from the working group policies of Kubernetes with several other people from the policy engine community. They have done a great job, to be honest. And I'm super happy that it's there. And you can use it. That's what next? What's next, for example? Another option would be another DSL. Maybe you don't like Rego, but you are not into YAML or whatever. How about Cell? Do you know about Cell? Does anybody has heard about Cell here? I see less hands, but yeah. Thanks for raising the hands. I understand that it can get tiring, but I appreciate it. So it's another DSL. Cell, the interpreter is written in Go. So then we can compile the interpreter from Go into WebAssembly, put it in a policy, and provide the cell in the settings of the policy. That would be a solution, for example. We have already done a minimum proof of concept, and it can be done. Maybe the next thing to do is just add another SDK for a language, maybe for your preferred language. We have thought about Python, for example. There's several that already support WebAssembly. That could be an approach. Maybe you would like to have all of this inside of the Kubernetes API server instead. You are tired of these controllers and Helm charts and these and CRDs. And you want this by default. Well, we have already had a proof of concept of this. Actually, a colleague presented that, Flavio presented that last KubeCon of last year, and it works. You can just put the policy server, that is the one that evaluates the policies inside of the Kubernetes API server, and then it's quite minimal, no big explosion of things, and it can be done. Maybe what you are missing is a lot of policies. Maybe you would prefer to have way more policies. Well, we can write them. And maybe you're a company and have an idea of a startup or whatever, and you want to write that policy, but you don't want to actually ship that policy because you want to build a product from it. You can do that. Maybe you want to reuse the whole Kubewarden as a policy engine, as a admission or a mutating webhook thing for whatever you are using, because you have your thing to do and just you need a tiny bit of policing and that's it, or compliance. Or how about being generic beyond Kubernetes? Maybe you know about OPA, which provides policies outside of the cluster. We can do the same here. We don't need the controller. We have the policy server. How about taking the policy server binary, which is a CLI, and running it outside with policies that get fed whatever data from wherever. You can run it also in a container or use Kubernetes as a control plane and so on. But it's doable. It's possible. OK. So yeah, I hope that with this I have a bit convinced you that this is possible, at least, and maybe shown you a way of doing different things. And with this, what can I tell you? Try it. If you're interested, try it. Maybe you already know about it. There's more features coming. If you want to try it, the web page is kubewarden.io. The policies, the public ones that we have, are on artifacthub.io, because we are a CNCF project. And just come tell us. You can open an issue happily on GitHub or a PR if you are inclined. You can come to Slack. The channel is Kubewarden on Kubernetes workspace. You can use the app formerly known as Twitter. We have a handle named Kubewarden. Or you can join our community monthly meetings, for example, every Thursday on the second week of the month, or on conferences. So if you see me around, just ask me any questions. And I think that's it. Many thanks.
Cool. Thanks, Victor. We do have a few questions, and we've got a bit of time. So the first one I'll ask is, and you kind of touched upon it, how does Kubewarden compare to Governo? What are the benefits?
Yeah, totally fair. I feel like it's the whole point of the talk, so it's a bit more convoluted. What I can tell you is that we do intend to have a docs page with a comparison. It's not an easy thing to do, and one needs to be also, be a nice person when doing the comparison, because different tools have different usages, and one is not maybe knowledgeable about the whole stack of Kyverno and so on, but all of this is open source and so on. So what I can tell you is watch the talk and look for the docs in the near future.
Yeah, fair enough. Other policy engines, SysDic, StackRox, also look at runtime behavior. Example, Netcat processes started. Can Kubewarden identify such things?
Right now, not. But we can, Kubewarden has the idea of context-aware policies. We could provide a sidecar or a man in the middle, so to speak, for the networking, and just have a policy that runs that. So we can even provide kind of like a slim policy that uses other policy engines or other tools and queries those tools. So it's totally doable. If you are interested, please open an issue on GitHub, and we will be happy to do it.
Yeah, open source, as always, needs the community to get involved. Using Kubewarden and compiling policies feels quite cumbersome compared to text-based policies in Kyverno. What is the benefit of compiling policies? Well,
you don't need to compile policies. That's the whole point. You can just take the policy that has been already written and pass the settings as in YAML, as you would do with Kyverno. So if you are there and thinking that you don't want to compile policies, maybe it's that you are thinking with the persona hat of not a policy consumer. Sorry, you are thinking with the hat of policy consumer, and that's totally fine. Just consume policies. You don't need to write them. So I suppose writing, it's for a different persona.
Thanks. Can Kubewarden also policy non-Kubernetes resources? Example, policies around the provisioning configuration of resources in the cloud account.
Not yet. We do have an issue from the community asking for this, and it's totally doable. So I can tell you what I can tell you is stay tuned.
Watch the space.
Yes.
Cool. Or get involved. Talk to Victor. Does Kubewarden support mutations?
Yes. Yes.
Fairly simple. What possibilities are there to test policies written for Kubewarden?
Whichever if you think about the language, the same way that you could test that language, for example. You have kwctl, which is a little CLI binary that has the same code path as it would happen in the cluster. So just use that for CI/CD, test the language beforehand that you have written with whatever you are using. Maybe if you are using Rust, use Clippy, those kind of things, as usual.
Yep. Test-driven policies.
That's all our policies are done that way with unit tests, integration tests. So
Are there community-supported shared policies?
There are. I've seen some. Now the question is, do they want to publish them somewhere to, for example, Artifact Hub and so on? That's a question to them. We do get in contact with those kind of people if we see that there's a policy for Kubewarden from the community, and that's what I can say.
Do you publish it somewhere?
All our policies from the Kubewarden team are on artifacthub.io, which is a page that aggregates all artifacts from CNCF projects and so on.
Cool. And final question. Kyverno is often a single point of failure in clusters. If it breaks or fails, it can make a whole cluster collapse. Are such issues overcome with Kubewarden?
This is a tricky one, and I like it. Yes and no. So we are a policy engine. If you know about the Kubernetes API server, it provides some webhooks as an entry, which are admission and mutating webhooks, and that blocks everything that is going to the cluster. And we basically just plug there. If Kubewarden or Kyverno were to stop working as it should, just stop working, for example, then nothing can be changed in the cluster, which it's not ideal. That means nothing that needs to change, not even for the control, for the control plane of Kubernetes could also stop. we do take care of those things. We do provide a wide list of things that you can modify. We do take care to have things that know how it should behave when it stops working. But it's how it is. If you want this to change, then maybe we could talk about having like a button for reset, That's also on the features possible features. Or we could just put Kubewarden inside of the API server and get rid of those webhooks, for example. There's other ways, but yeah.
Cool. That's it for questions. Thanks again, Victor.
Many thanks.
Round of applause.
Thanks.